Okay guys, so we're going to do a quick little review for chapter 6. Chapter 6, remember we've been doing the states of matter. So on this side you've got the 4 states of matter: solid, liquid, gas, and plasma. And your solid is your matter that is fixed shape, fixed volume. So the particles move slowly. They vibrate in place. They don't change position, but remember they vibrate in place. So in a solid you have fixed volume, fixed shape, and they vibrate in place. And an example here for a solid is ice. Liquid has no fixed shape and a fixed volume. The molecules can move past each other. They still move fairly slowly, and liquid takes the shape of the container. So it takes the shape of whatever container it is in, so it doesn't have a fixed shape, but it does have a fixed volume. The volume stays the same. And an example of that is water. Gas, the particles are free to move, and they fill up and expand to fit the parameters of a container. So the particles are really far apart, they move very quickly, and there's a lot of space in between particles. And an example here for water, again, would be steam. Water as vapor or steam. And then the last state of matter is plasma, and that's an ionized gas. For example, lightning would be an example of a plasma. The particles are really far apart, again, like in gas, but now they have an electrical charge. And that's what the 4 states of matter are. Then we talked about energy. We talked about potential energy, which is stored energy. Kinetic energy, which is the energy of movement. When you put those two together, the potential energy plus the kinetic energy, you get thermal energy. So thermal energy is potential energy plus kinetic energy. And then you have temperature, and temperature is the average of the kinetic energy, the average of how fast or how slow the particles are moving. So you have potential and kinetic. They each have their own definition. When you add these two together, that's your thermal energy, and then your temperature is your average kinetic energy. Okay, so for changing states, we've seen this graph. This is a phase change graph. Changing states on the graph, anytime you have a flat line, that means you are changing states. Okay, because the temperature stays constant during a change of state. While you're melting, if you've got solid, say ice, it gets to 0 degrees Celsius. While it's melting, it doesn't all instantaneously melt at 0 degrees. It takes this time frame, okay, for all of the water to become liquid water, for all that ice to melt to 0 degrees Celsius. Then once all of it hits 0 degrees, then the temperature starts to go up, and it starts to boil here and vaporize, and then it takes this amount of time for it all to vaporize. And that goes in both directions. So if you're a gas, it hits the condensation point at 100 degrees. All of it has to condense before the temperature can keep going down. So making sure that you realize the flat parts of the graph are where something is changing state. Temperature point. So the melting point and the freezing point are the same temperature, just opposite processes. So melting and freezing, when you're melting, you're going from solid to liquid, and freezing, liquid to solid. If they have the same states, that means they are the same temperature, just from opposite directions. So boiling and condensation point are the same temperature, opposite processes, because boiling, you're going from liquid to gas. Condensation, you're going from gas to liquid. Same two states, just coming from an opposite direction. All right, sublimation we looked at in our dry ice lab, and deposition as well. Sublimation happens when you have a solid to a gas with no liquid state, and deposition is gas to solid with no liquid state. So your sublimation we saw was the dry ice block going from a solid directly to a gas with no liquid state. And then we saw frost form on those coins, water vapor in the air, going from gas directly to a solid, deposition onto the coin. Okay, so make sure you know the difference between those two. Okay, so now you have 8 questions. I'm just going to run these questions through, pause on each question so that it stays on there while you answer. All right, good luck.